All right, the very last thing that we've done in this unit is graphing from standard form. So just a quick reminder, in standard form, we can easily see our y-intercept because remember, the y-intercept of any function occurs when x equals 0. So like if I plugged in 0 for x's, I would have 0 squared plus 6 times 0 plus 8. So this c value is always our y-intercept. So my y-intercept is located at 0, 8. But to get to the rest of this, we need this in factored form. So I'm going to just real fast factor this, like, I'm still having trouble with my stylus. So I could draw the area model. You may find that you don't need the area model anymore, but we can still draw it. Let's see if it'll let me draw it. All right, so if we did our area model, we'd be thinking, all right, what multiplies to 8x squared that has a sum of 6? Well, that's going to be 4x and 2x. So when I factor this, I get x plus 4 times x plus 2. So in factored form, x plus 4, x plus 2. All right, so now when we find our x-intercepts, remember, this is where y is 0. So if I set this equation in factored form equal to 0, we learned that this is called the zero product property, that basically any value of x that makes either of my factors 0 is going to make our y value 0. So one at a time, we want to consider each of these. Like if x plus 4 equals 0, I could just subtract 4 from both sides, and I would get x equals negative 4. So one of my x-intercepts is when x is negative 4, and of course y is 0. The same thing here, if I set this this factor, x plus 2, equal to 0, I just subtract 2 from both sides. X is negative 2, so that gives me my other intercept. All right, for our line of symmetry, we said that always is going to go exactly between our two x-intercepts. So one easy way we could find our line of symmetry is just to average those two numbers, or to find the median of those two numbers. In this case, the mean and the median of two numbers would be the same. So if I average them, I could say like negative 4 plus negative 2 divided by 2, and that is negative 6 divided by 2, which is negative 3. So our line of symmetry is where x equals negative 3. And the reason we want to find that first is we know that that is the x value of our vertex. So once we know that x is negative 3, to find our vertex, we could substitute negative 3 for x into any form of our equation. Like we could use the standard form or the factored form. I think it's easier to do in factored form, but you could do either, or you could do one and then use the other to check. So if I plug in negative 3 for x, well, negative 3 plus 4 is positive 1. Negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. So my vertex here is at negative 3, comma, negative 1. All right, so now when I graph this, I'm going to try to graph it in such a way that all of this fits on my graph. We shall see if that works out. I'm just going to make my x-axis really low for that to happen. All right, so we said, again, you could put this down in any order. I like to do my x-intercepts first. So if I go out 1, 2, 3, 4 at negative 4, oh, this pen's driving me crazy. That's going to be one of my x-intercepts. The other one is at negative 2, and we said our line of symmetry is right here at x equals negative 3. Sometimes it helps me to draw that line of symmetry in. Okay, well, maybe. All right, I'm really going to get a new battery after this question. All right, so then my vertex point is at negative 3, comma, negative 1, so right here. And then we said our y-intercept is at 8, So if I go up 1, 2, 3, 4, 5, 6, 7, 8, my y-intercept is right here. And I could use the line of symmetry to get one more good point from my graph, that if this is 1, 2, 3 to the right of my line, I should have a point 1, 2, 3 to the left of my line there. We could use our pattern where a is 1 to find other points if you wanted to. So like again, over 1 up 1, over 1 up 1, 2, 3. And then it should track that this last point is over 1 up 1, 2, 3, 4, 5, which it is. So we could use that pattern to kind of check our work. Since a was 1, we know what to expect. All right, so we get this. All right, in the second equation, same thing. If we start with our y-intercept, it's just negative 10. So our y-intercept is 0, comma, negative 10, because that's what I would get if I substitute 0 for x, and the y-intercept is always where x is 0. To get our x-intercepts, again, we've got to go through this process of factoring, but notice all three of these numbers are divisible by 2. So to help us out, let's start by just pulling out a 2 and thinking of this as like two rectangles of x squared, oh my goodness, x squared plus 4x minus 5. So really, by doing that, I can ignore the 2 when I'm factoring and just factor this part. So if I'm like, okay, what multiplies to negative 5 and has a sum of positive 4? Well, that's going to have to be positive 5 and negative 1. So we get x plus 5 and x minus 1. So our factored form is, oops, we can't forget our 2. 2 times x plus 5 times x minus 1. All right, so to get our x-intercepts, if I set each of those factors equal to 0, well, if x plus 5 equals 0, x would have to be negative 5 for that to be true. So negative 5 comma 0 is one of our x-intercepts. And if x minus 1 equals 0, x would have to be positive 1 for that to be true. So 1 comma 0 is our other intercept. All right, so now to find the line of symmetry, we could just think what number is exactly between negative 5 and positive 1 on the number line. And if we're not sure, we could just think of like literally averaging those two numbers. So negative 5 plus 1, come on, pen, negative 5 plus 1 divided by 2. Well, negative 5 plus 1 is negative 4, and negative 4 divided by 2 is negative 2. So negative 2 is exactly between negative 5 and 1. And again, the reason that line of symmetry helps us is that our vertex is on our line of symmetry. So our vertex occurs when x is negative 2. And to find the y value, we could plug x is negative 2 into any of these forms. I could plug it in here, I could plug it in here, I could plug it into factored form. And you know, my opinion is that factored form is the easiest to deal with. So if I think about it, y is 2 times negative 2 plus 5 times negative 2 minus 1. So that is 2 times 3 times negative 3. And let's see, 2 times 3 is 6, and 6 times negative 3 is negative 18. So our vertex is at negative 2 comma negative 18. So when I scale my graph, I might need to count by like 2s or something to make it fit. So I'm going to go backwards and say, like, if this is, let's see if we can make it fit. So like negative 18, I'm going to count by 2. So negative 16, 14, 12, 10, 8, 6, 4, 2, 0. I'm just going to personally put my x-axis up here so that there's room for it. All right, so again, we're counting by twos. If you graphed yours and you're just using this video to check and you did it differently, I mean, that's fine. Okay, so probably don't have to label all of them, but let me just make sure I didn't make a mistake. -14, -16. Okay, that works out. All right, so if we plot our intercepts on the x-axis, I'm just going to count by ones. So 1, 2, 3, 4, 5. That's a -5 and a +1 right here. Okay, so our x-intercepts are at -5 and +1. We said our line of symmetry goes through where x is -2. So this would be a good line of symmetry. We said our vertex is always on the line of symmetry. That's at -2, 18. And then we know our y-intercept is 0, -10. So I could also find the kind of mirror image of that point on the other side of the line of symmetry. So now, let's see. So as we check this, when we use our our pattern to check, it might seem like, I'm going to be honest, for a second I thought I made a mistake, but I totally forgot that I was counting by twos on my y-axis. So if I check this with my pattern of 1, 3, 5, 7, looking for our first order differences pattern, we know since A is 2, what we're really counting by should be 2, 6, 10, 14, and so on. So if I look, when I go what looks like I'm going over 1 up 1, remember I'm really going over 1 up 2 because I counted by twos on my y-axis. So it looks like my next point is over 1 up 3, but it's really over 1 up 6 because I'm going from -16 up to -10. So for a second there I was like, oh my gosh, did we make a mistake? But no, because I scaled the y-axis by twos. All right, so once we have, and you don't have to go back and put these 2 points that I added, but I was just checking to make sure that I didn't make a mistake. All right, so for this last one, we know already, just from looking at this, that our y-intercept is going to be at +24, because if I plug in 0 for x there, I'm going to get -0, plus, which is just 0, right? 0 is not positive or negative, plus 5 times 0, which is 0, plus 24. So again, our y-intercept is probably the easiest thing to find, at least when we're in standard form. To get to my x-intercepts, though, we're going to have to factor, and again, because A is -1, I really need to factor out a -1 first. So I'm going to have a positive x squared, a -5x, and a -24 when I pull out the -1. So when I go to factor this, I'm thinking about numbers that multiply to -24 and have a sum of -5. So let's see, 1 and 24 won't work, 2 and 12 won't work, but what about 3 and 8? If we had a -8x and a +3x, that would add up to -5 and multiply to -24. So we get x minus 8 and x plus 3. So in factored form, we can't forget that -1, it's really important, but we have x minus 8 and x plus 3. All right, so now when I find my x-intercepts, again, that's where y is 0. Well, if x minus 8 equals 0, then I know x equals +8. So I should have an intercept at 8, 0. And if x plus 3 equals 0, then x must equal -3. So when I'm doing this, I don't need to worry about the -1 because we're in factored form, and -1 itself can't equal 0. So I'm just thinking what x values could make this factor or this factor 0, since I know -1 itself is not 0. All right, so we get our two x-intercepts. So now to get the line of symmetry, again, I could think what number is exactly between 8 and -3 on the number line, or I could just average them. So like 8 plus -3 divided by 2. Well, 8 plus -3 is 5, so 5 divided by 2. All right, so 5 divided by 2 is 2.5. So we do get a line of symmetry where we're going to have to deal with a fraction a little bit. So I could either think of it as 5/2 or 2.5, whatever you prefer. And that's a little bit of a bummer because now to find our vertex, I got to deal with that decimal or fraction, if you want to think about it as 2.5 or 5/2. So again, to get my vertex, I'm going to use factored form. You could use any form. I think factored form is easiest, but I've got the -1 out front. I'm substituting 2.5 for x, so 2.5 minus 8 and 2.5 plus 3. Yuck. All right, so I've got 2.5 minus 8, which is what? Oh, sorry, keep my -1. You know I'm bad at subtracting in my head. That would be what? -5.5. All right, and then 2.5 plus 3 is positive 5.5. All right, so when I multiply those numbers together, I get -1 times -5.5, which is 5.5, times positive 5.5. And then I just have to multiply that out. And you can use a calculator for this part. Why not? So I'm going to do that off screen with my calculator because my brain is way too dead this morning to do it the other way. Oops, my battery's about to die. All right, so that should be 30.25. All right, so this is a little yuck, but I'm just gonna, oops, sorry, another teacher's texting me. I'm just gonna do my best to graph this. So we said 8, 0, -3, 0. I'm just gonna put my points at 1, 2, 3, -3, and 1, 2, 3, 4, 5, 6, 7, 8, positive 8. All right, we said our y-intercept should be all the way up at 24. You know what? I'm just going to count by fives. We're just going to rough this. So I'm going to say 5, 10, 15, 20, 25, 30, 35. And we're just going to do our best approximation. So if our y-intercept is at 0, 24, that's about here. And we said our vertex is at 2.5 comma like 30.25. I'm just going to say that's about here. And then I'm going to kind of estimate my mirror point out there. And then I'm just going to do my best to draw this parabola. It's not great. All right, that's it.